Hey everyone, welcome back. In our last video, we explored the world of arrays and matrices in Matlab, learning how to create them, manipulate them, and perform some basic operations. Now, sometimes we may need to restructure the data to fit the analysis that we want to do, or flatten a higher dimensional array for data compression. For that, we have the reshape function in Matlab. The reshape function has three inputs: the array we want to resize, the number of rows over the desired array, and the number of columns in the desired array. So when I run this code here, uh, the reshape function fills the new array in column major format. That is, the new matrix is filled starting with the first column. So the first element of the original vector, it goes here. The second element, it comes here. Likewise, once the first column is full, elements get added to the second column. So after filling in four elements here, the fifth element gets placed here in the second column. So then the third column until we have a 4 by 3 matrix like we wanted. Now we also we can also reshape the new matrix that we have just restructured and created. So when I hit this code here, this reshapes the restructured matrix A. So here too, elements get taken from A, going down the columns from left to right, just uh, one column after the other, just like before. Now, note that all the three arrays, that is the original vector uh, and the restructured matrices A and B, all these have the same number of entries, in this case 12. So if we try to reshape the array into another array with a different number of elements, we get an error in MATLAB. So if I change this 4 here to some number 5 or some other number, this changes the number of elements in the restructured the in the desired matrix. So here it was 12 and here it's 15. So when I hit enter, MATLAB will show an error. Now, uh, suppose if I want my desired matrix to have, say, two rows, and I am a bit lazy to calculate the number of columns corresponding to two rows. So we can do a bit of math to see how many columns we need. But if I'm too lazy, we could leave one dimension unspecified by passing square brackets. So when I hit enter, here, as you can see, the reshape function in MATLAB automatically picks the correct dimension corresponding to the number of rows which I had entered, which was 2. Now, suppose I want to have a vector with, say, 6 columns, but I am too lazy to calculate the number of rows. So do, when I hit enter here, so 6 columns, 6 rows, and I'm lazy to calculate the number of columns. When I hit enter, see, it creates the required matrix for us. It calculates the number of columns for us. Now, you can use the semicolon enclosed, the colon enclosed in parentheses to create a single column vector from the columns of C. So when I hit enter here, as you could see, a column vector is created from the elements of matrix C in column major format. Like I said before, MATLAB reshapes data in column major format. If we want to manipulate our data row-wise, we can just put the transpose operator uh, before with the original array as the function argument. So when I put the transpose of the original array as the function argument and run this code, here the vector, the matrix created is in row major format. So if you compare it with the original vector we had, So see, uh, the elements are getting filled in row major format. So 2 comes here. The next element 3, it doesn't go here in the second position of the first column, but it goes in the second position of the first row. The third element comes here, and so on it goes. So this is how you reshape data in row major format. So this was all about reshape function. Now let's look at array indexing in Matlab. Now referring to elements in an array in Matlab is called indexing. Indexing is how you extract and modify values in arrays. For example, if you want the fourth element of this vector v here, you type v parenthesis 4. Now this will return the fourth element. Now you can also change the value at that position if you want. So if I type v parenthesis 4 is equal to 5, and then I print if I print the matrix here, uh, the third element, the fourth element, it was initially 3. Now it gets converted to 5 here, 5 here. So you can change the value of array elements like this. Now remember that MATLAB uses one based array indexing rather than zero based array indexing, unlike most popular programming languages like Python, C, and Java. So one based array indexing means that the index of the first element in the array is 1, not 0. So here the first element is accessed using the command v parenthesis 1. So when I hit enter, I get the first element of the array, which is 2. Now, whereas in zero-based indexing languages, the first element would be accessed using the command v of 0. Now, this distinction is important to remember when switching between MATLAB and other programming languages to avoid errors. Now, you can also extract a range of values using the colon with the first and last indices of the range. So if I want to extract elements from index say 4 to index 7, I just type v4 colon 7. Now this will return to me a row vector of elements from index 4 to index 7 from the original vector v. Now, um, to extract values from a matrix, we need to specify two indices. The first index is the row number, and the second input index, is the column number. So if I want to extract the element in the element placed in the first row and third column, I type M1 3. Now this will return to me the element in the first row and third column, which is 3. Now, sometimes we need to extract the whole row or the whole column of a matrix. Here we use again the colon operator. Now, colon operator in this case means for all. So if I write m parenthesis 2 comma colon, this will return the second row of vector the vector m of the matrix m. Now here if I type m um, colon comma 3, this will return to me the third column of m. So when I hit enter, see this the first command, it returns the second row, and this command here, this returns the third row of the original matrix m from the original matrix m. Now to we can extract the last element of a vector by typing the vector name parenthesis end. So when I run here, run this code, I get the last element of the vector v, which was 4. Now Remember what a colon operator does. It returns us a vector like we had seen in all these cases. Now, uh, so if I type v parenthesis 1 colon 4, it turns out that we are indexing to a vector with another vector, a vector of indices. So v1 colon 4 and v of vector 1 2 3 4 both are one and the same. So when I hit enter, see, both are nothing but the same. Now, so if I need the second, fourth, and eighth vector of eight elements of a vector, just create a vector containing those indices and use it to index to x. So you can enter indices in any order if you want. So if I run this code here, it will return the second, fourth, and third element of v and eighth element of v. And here, the second command, it returns to me the second, fourth, and eighth element, but in a different order. Here, the fourth element comes first, the eighth element comes second, and the second element comes third. So you can enter the indices in any order you want. The order listed in the index vector is the same order the elements get returned. Now, you can use multiple indexing to assign multiple elements at once. If you assign them a scalar, then all the indexed values will be changed to that number. So if I want to change fourth and fifth elements of vector v to 10, just type v 1 4 colon 5 is equal to 10. So and when I hit enter, see here the fourth and fifth element of the original vector v, it gets changed to 10. uh, Now, let's look at logical indexing in Matlab. Logical indexing in Matlab is a technique that allows us to select and manipulate elements of an array based on their logical value, that is, their truth or falsity. A logical array in Matlab is an array of ones and zeros where 1 represents true and 0 represents false. Now, these arrays are the result of logical and relational operations and can be used to index into other arrays. We will see logical and relational operations in detail in another video. But here for this, just understand that you can create a logical array by performing a logical operation on an array. So see here in this example, if you want to have an array v, an array, uh, you can create a logical array that identifies elements greater than 5. So if I type v greater than 5, this will return to me a logical array which is greater than 5. Um, so when I run this, see here, this command logical array is equal to v greater than 5. This gives me a logical array where ones are in the position of elements whose value was greater than 5 in the original array v. So here the third element, the first and second elements, they were less than 5. So we have 0 in their place. Now from third element to 4 5 6 7 8 element, the eighth element, the numbers, these numbers, they were greater than 5. So we have 1 at their corresponding places. Now at the eighth place again, the value 3 is less than 5. We have 0 9 1 3. Now all these 8 8 9 and 10, these elements, they had value less than 5. So we have 0 at their corresponding places. Now this is how logical arrays are created in Matlab. Now we can pass this logical array to find, uh, to extract the elements which were greater than 5. So if I run this code here, here I get all the elements in my vector v which were greater than 5. So there were 6 elements which were greater than 5 in the original vector v, and I get all the 6 elements here in the new vector answer. Now, so this will give you a row vector of all the elements in v that are greater than 5. Now, to count the numbers of elements greater than 5, we can count the number of non-zero elements in the logical vector we had just produced here. So we can use the n z function. The n z function counts the number of non-zero elements in an array. So when I type n z parenthesis logical array, it returns to me the number of non-zero elements. Now, the number of non-zero elements in logical array is essentially the number of elements in uh, the original vector v which were greater than 5. So when I hit enter, I get the number of non-zero elements which was 6. Now there were 6 elements in the original vector which were greater than 5, and here nz counts the number of non-zero elements in the logical array, which returns us the answer 6. So in this video, um, we had seen the reshape function. Now how we index elements in an array, and in the next and at last logical indexing, and we saw the versatile nature of colon function, colon operator. And now in the next video we'll see some more functions and operations related to matrices and arrays. Thanks for watching. See you guys in the next video.